questions 11 through 20 on the 2005 Grade 12 AMC 12B. An envelope contains 8 bills, 2 1s, 2 5s, 2 10s, 2 20s. 2 bills are drawn at random without replacement. What is the probability that their sum is $20 or more? So we got 1, 5, 10, and you've got 20. Now, because each of them has 2, I'm going to label them 1 and 2 to sort of make them distinct from each other, because they are. So I want to choose 2, and then I've got to make sure that $20 or more is their sum. All right, let's say I chose $20. If I add any of these, 1, 1, 5, 5, 10, 10, and the other 20, I'll get a sum of 20 or more. In a very similar way, if I took the other $20 bill, in an identical way, in fact, if I choose any of the other bills, the sum will be 20 or more. All right, we're done with the 20s. How about the 10s? Well, the only way I can get a sum of 20 or more is if I use either the 20s or the other 10. Correct? Because once I get down to 5, it'll be $15, and that's not $20. So there you go. Now I've done the 10s. How about what's next here? The 5s, right? The 5s, the only way I think is with the 20. Yeah. And in a very similar way, the other 5. And finally, I'm down to the $1 bill. The only way is with the 20s. All right, so I hope you understand what I did there in a very manual way. So now I just count them all up. This is 7, this is 7, that's 14. 3 is 17, 20, 22, 24, 26, 28. 28 ways. Now it's a probability question, right? Yeah, it's a probability question. So 20 is my numerator. My denominator is basically the total number of ways. Well, I've got to choose 2 bills out of 8. So for the first bill, I've got 8 possible choices. For the second bill, I've got 7 possible choices. So that's 56 because I multiply them. So 28 over 56 is my probability. And in lowest terms, that's 1/2, right? So 1/2 is the answer for 11, and that is D. The quadratic equation x squared plus mx plus n is equal to 0 has roots that are twice those of x squared plus px plus m is equal to 0. And none of m, n, and p is 0. What is the value of n over p? That is what they want us to figure out. And it's a numerical value since all their answer choices are numbers. So x squared plus mx plus n is equal to 0. And x squared plus px plus m is equal to 0. Now, in this question, we're going to use those 2 famous rules that the sum of the roots are equal to minus b over a, right? For any polynomial that's of the form ax squared plus bx plus c. The sum of the roots is minus b over a, and the product of the roots is c over a. All right? So we're going to use that, obviously, in this question. So for this equation, I'm going to call the roots 2r and 2r2. Why? Because they tell you that this has roots that are twice the roots of that equation. So this would be r1 and r2, the roots. Just getting that directly from the question. I didn't make that up. That's directly from the question stem. All right. Now we get into these formulas here. So for the first one, the sum 2r1 plus 2r2 is equal to minus b over a, right? Well, what is minus b over a in this equation? Well, it would be minus m over 1. Correct? So that's about as far as we can go there. Now let's apply the exact same rule for this equation. The sum of the roots here is r1 plus r2, and it's minus b over a. So what's minus b over a here? It will be minus p over 1. Okay? And that's as far as we can go there. Now we are going to use the product rule, which is C over A for both of these. So the first one, our roots are 2r1 and 2r2, so the product is 2r1 times 2r2, and minus C over A, or positive C over A, I should say, in this equation would be just n over 1, I believe. Yeah, just n over 1. And on this side, if you use the same thing, r1 times r2, our C over A here is going to be just m over 1, I guess. All right, there you go. We've got our relationships, and now we can proceed with trying to find n over p. So let's see, what can we do here? Well, from the first one, this one right here, if I factor out a 2, I get r1 plus r2, correct? Now, r1 plus r2 is right here. It's negative p. So this becomes negative p, and that is equal to negative m. So therefore, 2p is equal to m. Correct? I'll just put a little red box around there because that's important. And then let's see what we can do over here. 2r1, 2 times 2 obviously is 4. r1 times r2 is equal to n. Now r1 and r2 we got over here is equal to m, so that means 4m is equal to n. Alright, so put a little red box around that one. And I think that's it. We can now figure out n over p, which is our goal. So n over p, well, n we just got was 4m. P from here is going to be m over 2, correct? So let's see here, 4m over 1, invert and multiply, 2 over m. And this just gives you 8 because the m's cancel. And there you go. That's the answer. So number 12, the answer is D. Suppose that 4 to the power of x1 is 5, 5 to the power of x2 is 6, 6 to the power of x3 is 7, and so on. 127 to the power of x to the 124 is 128. What is x1 times x2 all the way till x124? I'm going to use log in this question. Log of 4x to the power of 1 is log of 5. I'm just applying log to that guy right there. The x1 will come out front, and then therefore if you isolate for x1, you'll get x1 is equal to the log of 5 over the log of 4. Correct? Let's do the exact same thing to the next guy. Log of 5 to the power of x2 is equal to log of 6. x2 comes out front, and then we can isolate for x2, and it'll be the log of 6 over the log of 5. Right? Do the exact same thing to the next one. Log of 6x3 is equal to the log of 7. x3 comes out front, and therefore we've got the log of x3, or sorry, the log of 7 over the log of 6 is x3. And that's what I meant to say. And in a very similar way, obviously you get the hang of it, dot, dot, dot. I'm certainly not going to write them all out. It would be x to the 124 would be the log of 128 over the log of 127. Now let's tackle that guy right there, x1, x2 all the way till x24, right? So x1 times x2 times x3 all the way until x124. All right. Well, x1 we got right here is log 5 over the log of 4. x2 is here, log of 6 over the log of 5. These are all multiplications, right? x3, log of 7 over the log of 6. dot, 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 all the way till the very last one, which would be x124, which is the log of 128 over the log of 127, like that. Now the good news is a lot will cancel. That will cancel, that will cancel, and so on. All those will cancel. So you will, in the end, be left with just 128 log over the log of 4. All right? Now, the log of 128 and log of 4, how do I proceed? That's not one of the answer choices, right? I mean, the answer choices are these small numbers. Okay, no problem. All you have to do is convert those numbers to powers of 2. So the log of 4 is pretty simple. 4 is just 2 to the power of 2. 128 is 2 to the power of 7. So then, according to the log rules, the 7 comes out front. We get the 7 log 2, and the denominator, the 2 comes out front, like that. And then, therefore, the log 2 cancels on top and bottom, and you're left with just 7 over 2. And that's the answer to this cool question, number 13. Therefore, it's D. A circle having center 0k with k greater than 6 is tangent to the lines y equals x and y equals negative x and y equals 6. What is the radius of the circle? Let's draw a diagram and try to figure out what is happening in this question. So we have some sort of a circle here, right? And the center is 0k. All right, so I'm not sure what k is, obviously. I don't know. But I'm just going to say approximately here. I've got to put it somewhere. And I'll draw a circle where that is the center. All right, not perfectly drawn to scale, but that's okay. I think you will get the hang of it. And that's what diagrams are really for. They're just sort of to help you understand the question. So we got this circle. And it's got this center here at 0k. So this is 0k, that dot there, right there. And then k is greater than 6, okay, fine. And it's tangent to the lines y equals x. This is y equals x. And here's y equals negative x. And it's also tangent to y equal to 6. Okay, so I've got to draw a line y equals 6. So there you go. There's a line y equals 6. And that's all they give us, and they want you to find the radius of the circle. Okay. Where do I go from here? All right. A little bit of brainstorming here. Okay, well, they're tangent, right? So if you draw a line from the center to the tangent point, that's going to be a right angle. Correct? That's just a fundamental property of tangents. So let's just draw in a right angle right there, like that. Now, what do I do at this point? Let's see here. Well, this line y equals x is important. It's a very important clue because that means that it's cutting this quadrant in half. Like it splits it right down the middle. That's what y equals x essentially does. So that helps us because that tells me that this angle has got to be 45 degrees, right? Because this whole thing is 90. So if we're cutting that in half, that's going to be 45. Now this is already 90 degrees, so therefore that means this is 45 degrees, correct? Sum of the angles of a triangle are equal to 180. So if that's 45 and that's 45, then this is an isosceles triangle. Yeah. And this distance from the center to the tangent point is the radius, r. This is r. And if this is isosceles, that means this has got to be r as well. Correct? And then from here to here is also r. Just from there to there. Okay? I'll just call that r. And then this line is y equals 6. So this point right there is 6 on the y-axis. So the distance from here to here, right here, this distance, is 6. Okay? So therefore, I hope I haven't messed up the diagram. this triangle I will use to create a Pythagorean relationship. And that will be as follows. We got r squared plus r squared is equal to r plus 6 squared. Okay, so hopefully you're following. Nothing super fancy. So this becomes 2r squared. Multiply this out, r squared plus 12r plus 36. Put everything on one side. And we got, put everything on one side, I guess on the other side be a little bit easier. R squared minus 12r minus 36 equals 0. Unfortunately, I don't think this factors, so I've got to use a quadratic. That's okay. All right, let's use the quadratic here. So r is equal to 12 plus or minus b squared, which is 144, minus 4 times 36, negative 36, I should say. So that's another 144 all over 2. So this is 12 plus or minus 12 root 2 over 2. And just taking the positive one, that'll give me 6 plus 6 root 2. And that's it. So number 14 is E. The sum of 4 two-digit numbers is 221. None of the 8 digits is 0, and no 2 of them are the same. Which of the following is not included among the 8 digits? All right. So we've got 2-digit numbers, 4 of them. And we're going to add them all, and it gives me a sum of 221. And then they're saying which one of the following is not among these 8 digits. All right. There's quite a few ways of approaching this question. You can do it the long way. I just did it through a very quick trial and error. I just said, okay, well, I've got to choose numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I can't choose 0. So let's start plugging in numbers, see what I get. I'll just use the first 2, say 21. If I do that, I get basically 221 minus 21, which is, I've got a 200 left. All right, let's go to the other extreme here, and let's choose 98. All right, it's 200 minus 98. I've got 102. Okay, where can I go from here? So I thought, okay, let's just choose 67. Put 67 in here. Let's see what that gives me. And that gives me 35. And it worked out perfectly. The only one that I didn't use was 4. So 4 is the answer. Now the key to this question is to understand that when you make these numbers, none of these digits can be used more than once, right? No 2 of them are the same, because you can get a lot of combinations that add up to 221, but in a lot of those, the digits will be the same, like you'll have a 77 or you have an 88, and that's not allowed. So there is, of course, other ways of doing this question, but I just like the simplest way the best. So there you go. Number 15, the answer is D. 8 spheres of radius 1 per octant, are tangent to the coordinate planes. What is the radius of the smallest sphere centered at the origin that contains these 8 spheres? One of the keys to this question is to understand that these are spheres and not circles. Because if you do this question as a circle question, you won't get any of these answers. And also, if you do the question as circles, you'll be stuck in the XY plane. And therefore, it would be incorrect. The sphere is very important to understand, because that means you are now going to be in the XYZ plane, right? Because it's a 3-dimensional question now. And I'm sure you remember the XYZ plane, X, Y, and Z. And that's how this question is going to be set up. Now, do you know what octant means? Well, you definitely have heard of quadrant, correct? Quadrant is just this area right here. This is like the first quadrant, for example. Octant is if you were to cut that down the middle. Each of these would be octants. So this question, I think the hardest part, of course, is just the visualization of it. Once you visualize the way the spheres are set up, then it becomes relatively straightforward. So I'll try my best, but I have to kind of explain it in a way that's 2D. Now, if you have a sphere, right, and they give you a little bit of a hint that it's basically radius of 1. Okay, if it's a radius of 1, then that means that the coordinates of the center will be of the form 1, 1, 1 for at least one of those spheres. So to visualize it, let me just draw a circle here in the 2D dimension. So here's a circle that I've drawn in 2D, right? And if this is the center right here approximately, if you were to draw a line from the center of the circle to the x-axis, that would be 1 if this circle has a radius of 1. And in a very similar way, if you do the same to the y-axis, that would also be 1. So you can clearly see that this center is 1, 1. But we don't have a circle in our question, we have a sphere. So the sphere cannot be sitting like this, x, y. It will be moved 1 unit onto the z plane. Do you see what I mean? And that's why the center is 1, 1, 1 for at least that first circle. But we have 8 of them. So those circles that I drew here are actually going to be spheres, but in the XYZ plane. I hope that makes sense. And then once you do that, you'll be able to understand this question. So I'm just going to work with one of those 8 because all the other ones are identical. They're all 8 identical spheres. They're just 1 in each of these octants. So if I just use one of them, that's perfectly fine to figure out this question. So I'll just use the one that's in our first octant with the center 1, 1, 1. Okay? The first step is to figure out the distance from the origin to the center of that sphere. Well, how do you do that? Well, let's use just a simple distance formula. The origin, of course, has the coordinates 0, 0, 0. The center of our sphere, C, is 1, 1, 1. The distance is just basic distance formula. 1 minus 0, 1 minus 0 squared, plus 1 minus 0 squared, all under the square root sign. And this looks like 1 plus 1 plus 1, which is 3, so square root of 3. So the distance from the origin to the center of the sphere is root 3. All right? Now, if you've got a circle, let's see here, what is the radius of the smallest sphere centered at the origin that contains the 8 spheres? So we again have to visualize a bigger sphere that contains all of them. So it's something like this. You've got the first circle, and I apologize, I'm putting this again in 2D because in 3D I'd be way too confusing. I don't want to confuse you. So let me just explain it in 2D. Let's say you've got a circle and you've got another big circle that encompasses it. So like this. So you see how this scenario plays out? You've got our original circle here, the smaller guy. It's got a radius of 1. Okay? And then you've got this larger circle that encompasses it. And we want to figure out the radius of that larger circle. Okay? Now, our question is spheres, but I'm trying to explain it to you with circles. All right? So what we did originally is we figured it out so that the distance from the origin to the center of the sphere. So it would be basically from there to there, if that's the center of that circle. And then now we want to figure out the next component, which is essentially extending that line. So there you have it. Tried to make this as accurate as I could. It's a little bit challenging here, but the first distance, there you go. I just want to make it distinct. There you got your circle right there. And then I've got to convince you that you have this distance from the origin to the center of the sphere. So it's approximately from here to here. And then the remaining distance from here to here is just the radius of the circle. Correct? So this right here was root 3. Here is 1 because that's the radius. So the full distance from there to there is root 3 plus 1. Okay? Now, like I said, I'm explaining to you the question in 2D, but we are actually in 3D in the actual question. So this represents the radius of the sphere, root 3 plus 1. And therefore the answer to number 16 is D. How many distinct 4 tuples A, B, C, D of rational numbers are there with this expression equal to 2005? Let's work with this here. A log base 10, 2 plus B log of 3 to the base 10 plus C log of 5 to the base 10 plus D log of 7 to the base 10 is equal to 2005. So we've got log of 2 to the base 10 A, like that, plus the log of 3 to the base 10 B, plus the log of 5 to the base 10 C, plus the log of 7 to the base 10 5 is equal to 2005, like that. Okay, well, since all the bases are the same, we can combine these, right? There's that standard rule that if you have the log of A plus the log of B, that is equal to the log of A times B, like that. So we'll apply that rule here. So that makes this the log of 2 to the power of A times 3 to the power of B times 5 to the power of C times 7 to the power of D, all to the base 10 is equal to 2005. And then fundamental log rules, 10 to the power of 2005 is equal to 2 to the power of A times 3 to the power of B times 5 to the power of C times 7 to the power of D, like that. And then 10 can only be broken up into 2 times 5 in terms of its prime factors. So this is 2 to the power of 2005 times 5 to the power of 2005. It's the only way. There's no other choice that we have in terms of prime numbers. And that is 2 to the power of A, 3 to the power of B, 5 to the power of C, and 7 to the power of D. Now this has to match because they're equal. Well, 2 to the power of 2005 is 2 to the power of A, obviously. So that means A must be 2005. 5 to the power of 2005 has got to be 5 to the power of C. So that means C is 2005. But what about these guys? Well, they're not included. They're not invited. So B and D must be equal to 0. B must be 0, D must be 0. So our ordered 4-tuple, is that what they call it? 4-tuple, yeah. I think the only one is A, B, C, D is equal to 2005. Let's see here, 0, 2005, and 0. So there's only one. I can't see being able to find any others. So there's only one, so therefore number 17, the answer is B. Let A be the point 2, 2, B is 7, 7, and their points in a plane. Define R as the region in the first quadrant consisting of those points C, such that triangle ABC is an acute triangle. What is the closest integer to the area of region R? Let's draw this on a coordinate axes. Let's see what kind of scenario we get here. So we got X and Y. And then what are my 2 points here? 2, 2, and 7, 7. So approximately here, let's say, and here. So just those two representing the red dots right there. I'll just put 2, 2, and 7, 7. Now, this line I just drew connects those 2 points, okay? And that line, obviously, has got to be y is equal to x, since those 2 points, both the x-coordinates and the y-coordinates are the same. Now, those are A and B. Now, they want you to figure out some point C, and when you draw this triangle ABC, it's going to be an acute triangle, which means that all the angles of that triangle have to be less than 90. All right, how do I do that? Well, the first thing, of course, is I'm going to draw a boundary, an initial boundary, as follows. Now, that's my boundary. Now, you say, well, how did you figure that out? How do you know that C has to be within those 2 blue lines? Well, think about it. If C is here, let's say, and I draw a triangle like that, right? It looks like the angles will be less than 90. But if you go beyond, look at that. This angle, obviously, is not 90 degrees. It's much greater. This is a very important question to understand these types of triangles. This is 90 degrees right here. We can't go extend beyond that. We can't, for example, this line cannot extend beyond that. If it does, it becomes greater than 90 degrees. We can only stay inside. And in a very similar way, on this side, we can't go beyond 90 degrees. We can only stay inside. So I hope you're convinced of that. And I'm going to do this question in 2 parts. For those of you who already figured out how to do this question, you might be saying, well, you're missing something. Where's the part that you're missing? Why aren't you doing that? Because I want you to understand it. I want you to understand why this is incomplete. It's correct. We're going down the right path. But first, let's figure out this area. So we're just looking at the blue region. No problem. Seems pretty straightforward. All I have to do is just figure out the area of, looks like 2 triangles, and subtract them. But to do that, of course, first I need the coordinates. And then I can work from there. Now, this equation of this line, you can easily figure out. Why? Because its slope is going to be the negative reciprocal of this guy, because it's a line that's perpendicular. So if this line has a slope of 1, this line has to have a slope of negative 1. And therefore it's y equals mx plus b, so it would be x plus b. And to figure out b, you just substitute the 0.77. And if you do that, you get 7 is equal to minus 7 plus b, and therefore b is equal to 14. So this equation is y is equal to minus x plus 14. All right? And if you do that and you substitute x equals to 0, you get y is equal to 14. And if you substitute y is equal to 0, you get x is equal to 14. So there you got those points right there. In a very similar way, you can figure out the equation of that line. And it is y is equal to minus x plus 4. And therefore this gives you 4 and 4 as the coordinates. So now how do I figure out the area of this blue region or shaded region? Well, it's easy. You just figure out the area of the triangle and then subtract the small triangle. So the big triangle is going to be 1/2 base, which is 14 times height. Subtract the small triangle, which is 1/2 4 times 4. So that's 1/2 14 times 14 which is 196 minus 16. And this looks like 180 divided by 2, so 90. So there you go. That's the answer, right? Well, it's not one of the answer choices. So I say, well, then what did I do wrong here? I don't get it. I understand it. I'm convinced that this is right. So why is 90 not one of the answer choices? And I did that on purpose. I wanted to get to 90 and then think. This is a great question, or probably one of the better questions I've seen on a math contest. Here is what we missed. And I'm going to first draw something, and then I'll let you think about it for a little bit. And there you go. I just drew a circle. Say, well, what is the point of drawing a circle in here? Well, I'll explain. Let's say I draw a triangle, ABC, right? This triangle that we are most concerned with. And I draw that triangle inside ABC. Watch what happens. We get a scenario like this, like that, or any scenario. If it's touching the circle. Do you know what the angle is? This angle right here? The angle is 90. That's the fundamental rule. If you draw a triangle inside a semicircle, that angle is 90. So any triangle that's drawn inside that semicircle, like this, for example, or this, for example, will have an angle that's greater than a right angle. That will be greater than 90. So that will not qualify as an acute triangle. So that region cannot be included in this 90 that we just figured out. So isn't that great? That's a really, really good question. I mean, most of the time it's just the same thing over and over again, but once in a while you get a really cool question. So I've got to take this 90, that's perfectly fine so far, but I've got to subtract from it the area of the circle. No problem. 90 minus pi r squared. All right, so what's r in my case? Well, I've got to figure out r. The diameter of this circle is from this point to that point, right? From 2, 2 to 7, 7. So I can figure out that distance and then just divide by 2 to get the radius. So the diameter, first of all, is going to be 7 minus 2 all squared plus 7 minus 2 all squared, square root. So that looks like 5 squared plus 5 squared, so root 50. And that's 5 root 2, I believe. Right? But then the radius has to be half of that, so 5 root 2 all over 2. So plug that back into here. Pi 5 root 2 over 2 squared. So we got 90 minus pi. So that looks like 25 times 2, which is 50, divided by 2, which is 25. And that's 50 divided by 4, because it's 2 squared. Haha, don't make that kind of algebraic mistake. So that would be 12.5. All right, that's the answer after all that. And they want an integer value, so you take out your calculator, or you don't really need it. You can just use 3.14, and if you do that math, you'll get approximately 50.6. And therefore, number 18, the answer is C. Let x and y be two-digit integers such that y is obtained by reversing the digits of x. The integers x and y satisfy x squared minus y squared equals m squared for some positive integer m. What is x plus y plus m? X will let it equal ab, and therefore y will be ba, right? Reversing the digits. So this basically means 10a plus b in terms of a value. This is 10b plus a. And we are told that x squared minus y squared is equal to m squared. So if you substitute that in, you get 10a plus b squared minus 10b plus a squared is equal to m squared, like that. So this is 100a squared plus 20ab plus b squared minus 100b squared minus 20ab minus a squared is equal to m squared. So we've got 99a squared. The ab's, 20ab's cancel, and then 99b squared is equal to m squared. Factor out the 99, and then we got a squared minus b squared is equal to m squared. And let's see, more factoring, I think. 9 times 11, a minus b, a plus b. And I think that's about as far as we can go. And now what do we do here? Well, m squared is the square of an integer. They tell you that it's a positive integer. So that means that this side must be a perfect square. Well, if this is a perfect square, then that means that this, for example, could be 9, and this could be 11. If that is true, then we'll have a perfect square. We'll have 9 squared and we'll have 11 squared. All right? A minus b equal to 9, a plus b equal to 11. So adding these, we get 2a is equal to 20, and a, therefore, is 10. But that's not going to work because a and b are single digits. So that doesn't work. Okay, no problem. That's wrong. So how can we get a perfect square? Well, 9 is already a perfect square, right? Because it's 3 times 3. So how about I just leave this one alone? And then make this 11. That would be 11 times 11. And then make this 1. You see how I did that there? That could be another possibility. So let's see what we get there. A plus b I've set to 11. A minus b I set to 1. Now let's add both sides. We get 2a is equal to 12, and then a is 6. That works because a is now a single digit. Subbing this back, we get b equal to 5. All right, that'll work. That means that x is, let's see here, 65, and b, or y I should say, is 56. All right. So x is 65 and y is 56. And what do they want us to find? X plus y plus m. Okay, so I've got to figure out m. Well, m is here. It's x squared minus y squared. You can probably do this pretty quickly. X squared minus y squared is actually x minus y times x plus y, right? If you factor it out. X minus y, since this is x and this is y, x minus y is 9. X plus y looks like 121. And then if we want m, take the square root of both sides, so 9 times 11. And therefore m is 33. So there you go. We've got x, we've got y, and we have m. If you add them all up, 65 plus 56 plus 33 is 154. So number 19, the answer is E. Let A, B, C, D, E, F, G, H be distinct elements in this set. What is the minimum possible value of A plus B plus C plus D squared plus E plus F plus G plus H all squared? All right, in my humble opinion, a little bit of trial and error will probably be the way to do it. All right, let's see here. We want to get the minimum, okay? The first thing that I'm going to do is sort of write these out, and then I can just start crossing them out as I'm using them, these numbers. Okay, in the first set, right, A plus B plus C plus D, I want to get the smallest number possible. So if I'm going to put a 13 in there, I'm going to put a -7 in there, because that way it will start canceling. You know what I mean? And then similarly, I think I can probably keep going here. I can make it a little bit smaller, put a -5 in there. All right. So far, so good. Do I want to put another negative in there? Sure. And then that's it, because I can only use 4 terms. That's all squared. And then I guess everything else just goes into the next column, or the next section. -2, +2, 4, and 6. Oh boy, this is a lot bigger than I had hoped. But that's okay. Let's just figure out what this is. So this is -2 squared. And this one over here is 10 squared. Oh, that's huge. And that's not good. That's 4 plus 100. That's 104. That's not even one of the answer choices. All right. No problem. That's what trial and error is all about. Let's try again. So again, let's try to get this 13 as small as possible. -7, -5. And I think that's it. I'm not going to go any further. And so I got 13. I've got -7, -5. And let's stick in a 2. Let's save some of these other minuses. All right, and then for the other section there, I've got the other remaining numbers, -2, 4, 6, and then this -3 here, right? Okay, let's see what we get here. So this gives me 3 squared, and this over here is 10 -5, which is 5 squared. So this is 9 plus 25, well, that's 34. Okay, 34 is one of the answer choices. So obviously those two are out because 34 is smaller than those. Can I get 30 or 32? Well, one thing I immediately notice is that this expression is the sum of 2 squares. So if it's the sum of 2 squares, for example, we just showed 1, right? 3 squared plus 5 squared. The only way you can get something smaller than 34 is if you had 4 squared plus 4 squared. That would give you 16 plus 16, which is 32. 32 is the only other way that this could be smaller, but there's no way to get 4. There's no way of getting a 4 by combining 4 numbers from that list. And try it. You won't be able to do it. Yeah, if you go through that list, you'll see if you take any 4 numbers and add them, it will never come to 4. So that's it. 34 is the lowest. So therefore, number 20, the answer is C.